This is Juan Escalada, and this is my report for assignment 2. In this report, I'll be using the banana quality data set that I got from Kaggle to figure out what are the factors that contribute to the quality of a banana. We have a bunch of predictors, which are size, weight, sweetness, softness, harvest time, ripeness, and acidity, and then with this we can predict the quality of the banana. As you might see, these values are a bit weird on their own, but basically what this is representing is basically a mean of 0 and a standard deviation of 2. So we take these parameters into account when we actually ask users in the app. So first let's go through the exploratory data analysis. Basically we have half and half good and bad bananas in our data set, and the values for each parameter range from -8 to 8. And if we compute the standard deviation and the mean, it's basically around 2 for most parameters. So the mean is around 0 and the standard deviation is around 2. Then we use some box plots to just figure out, okay, is there any notable differences between good and bad bananas? And we can immediately see that size, weight, and sweetness are really influential parameters. So larger and more heavy bananas and sweeter bananas are of better quality than those that don't have those attributes. Harvest time is also quite influential. Then we did a few scatter plots to compare the two, and correlation matrix to see if there's anything that is very highly influential. So we notice that harvest time and size are both very positively correlated, as are weight and acidity. Those by themselves are not particularly interesting, but all these things can be used to create a good predictive model. So then we did some data treatment, and we found out, based on feature importances, that weight, harvest time, and sweetness are the most important features based on the random forest classifier. But other than that, we find that pretty much all of the variables, including acidity, do have a fair amount of predictive power. So this is why we did not remove any of the features. So in total, we have 7 features for this model. Then we did a bit of model development and comparison between. So we can see the cross-validated accuracy scores for the 11 initial models. And we have that the stacked model and the k-nearest neighbors models were the most highly accurate of the bunch. So in the end, we chose the stacked model to create our predictive model. Finally, we can go over to the banana classifier site. So this was done with Django, and the way we interpret these numbers, so notice how instead of having numbers to input, we just have options. So whenever the user picks average, this value turns into the median value, so 0. If the user picks, say, tiny, then the size turns into -5, which is about 2.5 standard deviations below the mean. Likewise, if you pick something on the other extreme, then you get 2.5 deviations above the mean. This just makes it a lot more user-friendly to, be able to classify the bananas. And then once we picked a bunch of attributes based on what our banana is like, then we can just click Predict Banana Quality, and we get a result. So in this case, the banana is good, and it shows us the information that we just input. On the other hand, suppose we have a banana that is tiny, it's not sweet, so obviously this is going to be a poor quality banana. And if we click here, we get that the banana is bad. And that is pretty much it for this banana classifier.